Hello class, and welcome to the lesson today, lesson 1 for unit 5. It will cover 5.1 graphs of reciprocal functions. Just a reminder of what the word reciprocal means. Okay, so reciprocal refers to any function that you take and put it under the number 1. So for example, that would be something of the form 1 over and then whatever the original function was, f of x. Okay. So let's get started into the investigation here. Today we are only going to work with linear and quadratic functions. So the first one is about linear functions and their reciprocals. So let's start off by looking how we graph the function y equals x minus 3. So let's just call this f of x for now. And in order to graph this, okay, we are going to use the slope of 1 over 1 and the y-intercept of negative 3. Okay, so we're going to go to our graph here. You're going to plot a y-intercept at negative 3 and then use a slope of up 1, right 1. And we should draw something that looks like this. We will have two graphs on this grid, so make sure you're drawing this in two different colors. We are going to draw the linear graph and then the graph of its reciprocal. So draw this and label it f of x with your arrows. Now we are going to complete the chart below, as part B says. So we're going to go down to the chart here. And for this first column, we have f of x equals x minus 3. So we have to first ask ourselves, are there zeros and or vertical asymptotes? There is one zero, and it's right there. Okay, so this is our 0. So that's at 3 and 0, and we have no vertical asymptotes for this line. Okay. So the 0 at 3, 0, and no VA. It's asking us for our y-intercept, and we can see that right from the b value. So we know that that's at 0, negative 3. Now it's asking us for the intervals where the function is positive. So that's another way of saying when is f of x greater than 0, or when is the graph above the x-axis. So our diagram is helpful here. We're going to go and see that the graph lies above the x-axis for this part here. So that's everything greater than 3. Okay, so it is positive for 3 to infinity if we use interval notation. And now we're going to do the opposite, the intervals where the function is negative, so where is it below the x-axis, and that will be everything to the left of 3. So we're going to come down here and say from negative infinity to 3. Now it's asking, excuse me, for the intervals of increase. This line has a positive slope, so therefore it is increasing at all times. So that means it's increasing from negative infinity to infinity. Intervals of decrease, there are none because it's always increasing. Now I've added these two rows in here. I'm asking what the x-coordinate is when y equals 1. So if we go up here, when y is 1, I go across to the graph, see where it hits the graph, and I come down and I see that it has an x value of 4. So we're going to come down here and say it has the point 41. Now I'm asking for the x-coordinate at y equals negative 1. So I go to negative 1 here. I go across to the graph, and it hits it at an x value of 2. So I'm coming down again, and I write that my x-coordinate is 2, and then y-coordinate negative 1. And these 2 points are going to be important when we go through the reciprocal. Okay, so now that we've done that, we're going to scroll back up and go to part C. And if you notice, the equation here is the reciprocal. So it's the reciprocal of f of x, because all we did was bring the x minus 3 down to the denominator and put it under 1. So we're going to call this g of x, okay? Or you can just label this as 1 over f of x. So we're going to get into how we draw something like this using properties throughout the unit, but right now the only way we know how to draw this is by noticing that it is the transformed function 1 over x shifted 3 units to the right, because it has the d value of 3. So let's set up our table of values. Our parent function we know has these key points, -1, -1, 1, and 1. And we know that it has at 0 that there's a vertical asymptote, so we know it's undefined there. So when we do our mapping statement, little table of values here, we know that x plus 3 becomes the new x coordinate, and the y values are not affected. So we get the point 2, -1, 3, and now at 3 it's undefined, so now there's a vertical asymptote at 3. And 4, 1. So we have vertical asymptote and we know we've got these 2 points. So start drawing that in now. And I have it saved over here as well. And this should be what our graphs look like all together. So drawing in, so that vertical asymptote at x equals 3, okay. Don't forget that we know all transform reciprocal functions of 1 over x also have a horizontal asymptote at y equals 0. Okay, so that's always a given here. So we should always have a vertical and horizontal here. And then we should have our 2 L brackets. And because it wasn't reflected in any way in the equation, that's why the 2 L brackets stay in these 2 positions as opposed to being flipped to these 2. So draw that in with a different color, okay, and label that g of x. So now we're going to go down to complete our chart. Okay, so g of x, 1 over f of x. So this one is asking, what are the zeros and or the vertical asymptotes? We can see that because there's a horizontal asymptote, the blue graph does not cross the x-axis. Okay, so no zeros, vertical asymptote at x equals 3. The y-intercept of this graph, so we can see that the y-intercept is right here, okay, right where I have the cursor. That's hard to tell from here, so we're going to find this out algebraically. So the easiest way to find a y-intercept is to let x equal 0. So we should have that work here. So we solve g at 0, and we get that that number is, so we sub it into that equation, we get that the number is -1 over 3. So that number in here, right, is -1 over 3. So we can plot that there. The intervals where the function is above the x-axis, where it's positive. So again, looking at the blue graph, where is the function above the x-axis? That occurs for this bracket here. So that is for all x values greater than 3. So it's everything to the right of the asymptote. So we're saying 3 to infinity. Where is the function negative? So that is this L bracket to the left. Okay, so that means it's all x values, so it's below the x-axis for all x values less than 3. So we're going to write that as -infinity to 3. Now we need the intervals of increase. If you notice here, remember intervals of increase or decrease are read left to right. As we move along, this function is always decreasing. So it will have no intervals of increase, but the intervals of decrease are going to be -infinity until 3, and then hop over the vertical asymptote and 3 to infinity. So -infinity to 3, and then 3 to infinity. The x-coordinate when y equals 1. So if we can tell on the graph here, and you can also tell by plugging it into the equation g of x, the graphs should intersect when y is 1 and when y is -1. So those should be two key points. So when y is 1, there should be a point of intersection, and when y is -1, there should be a point of intersection. So they should both have these points. So now the whole point of this is that you guys get to see the characteristics between a linear function and a linear function's reciprocal. So as we go through, let's take a look. The zeros of the original became the vertical asymptotes of the reciprocal. So that's one property we notice here. The y-intercepts. So whatever the y-intercept was of the original, the reciprocal of that value, okay, so when you flip it upside down, becomes the y-intercept of the reciprocal function. So keep in mind, this isn't like negative reciprocals where the sign changes. You just flip the number. Okay, so the y-intercepts should be reciprocals of one another. Where the function is positive, you should notice for both graphs, it is the exact same. Where both functions are negative, also the exact same. Now this part's interesting. The intervals of increase or decrease. We can see here I've drawn arrows to show that it kind of looks like they switched, right? None here became none up here. The unique part is, though, that they switch, but you also have to consider that there's now vertical asymptotes in the reciprocal. So none became none, and if you notice here, the two boundary values, so this one, the boundary values are -infinity to infinity. The one for the reciprocal has the same two boundary values at the ends, however, they just have to stop in between for the VAs. So you have to consider the vertical asymptotes, and the vertical asymptote was at 3. So you do -infinity, hop and stop at 3, hop over, start at 3, go to infinity. Okay, so that's the key part here. And for here, we should notice that these are points of intersection. So a graph and its reciprocal will always intersect where y is equal to plus or minus 1. So y. A lot of students will get this confused and say it's where x equals plus or minus 1. So please keep that in mind. Okay, I know this is a lot to take in. This lesson is a lot of information, but we're just going to do one step at a time. So if you're ready, let's move on to the next page. Now we're going to investigate quadratic functions and their reciprocals. So how is it different with quadratics? So let's start off with the function x squared minus 4. Okay, I'm going to label that f of x. Okay. So again, if we were to just graph this, I would notice this is a quadratic function that has been vertically translated 4 units down. So I start with my parent function, my table of values, and my c value is -4. So that means I know that my x's aren't affected, and I just subtract 4 from all the original y values. Okay, so you're going to draw these two, and then use these to draw a sketch. So your graph should look like this. Again, have different colors out. We will draw its reciprocal on this grid as well. Okay. So this should be our parabola. All right, let's use this to fill in the chart below, as part B says. Okay, so we're coming to this chart here. It's asking for the zeros and the vertical asymptotes. So it's got two zeros, one at -2 and one at 2. And because it's a parabola, it does not have vertical asymptotes. So 2 zeros. The y-intercept. So we can always find the y-intercept. We can easily see it here if we didn't just sub x equals 0. And the y-intercept is at -4. Now we need to determine where the function is positive. So notice that the function is positive in two different areas. It's positive, meaning above the x-axis, for all values less than -2. And then it's above the x-axis for this area, which is all values greater than 2. So we're going to come down here and we're going to write from -infinity to -2 in union with 2 and infinity. So that means the function is negative, so below the x-axis for this area here, and that interval is between -2 and 2. The intervals of increase. So the interval of increase is going to be everything from the minute you leave the vertex all the way to the right. So it's increasing here. So that's going to be from 0 to infinity. Okay. The intervals of decrease, that's going to be everything to the left of the vertical left of the vertex, and that's going to be from -infinity to 0. Now we need to determine the x-coordinates when y equals ±1. So coming up here, as you can see, it will be hard to tell sometimes. Okay. So when y equals 1 and when y equals -1, we can see that those aren't necessarily easy to see clear points. It's hard to tell what the x values are here. So sometimes we have to just do this algebraically. Okay. So at the bottom here, that. So when we do our work at the bottom here, so we're going to let y equals 1 into our equation. You set y equals 1 equals x squared minus 4. You bring the 4 over, you square root both sides, and you know that x equals plus or minus root 5. So that means the x coordinate when y is 1 is positive root 5 and negative root 5. So it actually has two places. And that makes sense up here, because you should get two values, right? You should get here, so this would be negative root 5, and here would be positive root 5. If you want to find it for -1, okay, you sub it in again, bring the 4 over, you get x squared equals 3, and then you get plus or minus root 3 as your two x values. And that makes sense again. If we go back up to y equals -1, we can see that would be negative root 3. Okay, and this point here would be positive root 3. Right, those would be the x values here. So those are going to be important, as those will, as we can assume, they may be points of intersection with its reciprocal. Okay, so we are done that. Now let's see the reciprocal. So if we were to graph the reciprocal, 1 over x squared minus 4. So this is very unique to us because we've only transformed 1 over x. Okay, now we've got a squared in the denominator, so this is a little different. So let's do some work here. Okay. So for this case here, I'm just having us create a table of values with some random numbers just so we can get an idea of where things go. So these are just some random key points I plugged in for x, just to give myself an idea of where to plot some things. Just so you know, we're going to go over this a bit more later, but this one will have a horizontal asymptote of y equals 0. So just like the question before, there is a horizontal asymptote. Some things we know about the graph just by looking at the equation. We know that denominators can never equal 0. So that means x squared minus 4 can never equal 0. That means, what are the two values that make this equation 0? So we factor this as a difference of squares. Okay, so this is a DOS. And then we get that the roots, if this were equal to 0, would be plus or minus 2. So essentially, we just found out the two restrictions. X cannot equal positive 2 or negative 2, as that would make the denominator 0. And mathematically, we know that means that the vertical asymptote is at x equals plus or minus 2. So I want us to draw that in. So we're going to draw a horizontal asymptote at y equals 0, vertical asymptotes, 2 of them, at x equals plus or minus 2, and then I also want you to draw these key points over here. And your graph, when we go through, and again, this is difficult just the first time because you haven't seen graphs like this before. So I have it over here. I'll bring it back to the other page. Should look like this. And I know this looks crazy, okay, but also kind of cool as well. Okay, so you should have your two vertical asymptotes. Okay. You should have two L brackets. Okay. So one L bracket's going to go here. And again, the way you can draw this more specifically without my guidance here would be to do a bunch of table of values with a bunch of numbers just to test it out. But obviously we're going to do this to save some time. Okay. And what's going to happen here is that we have this kind of quadratic / quartic shape. Okay, that's underneath here. So as you can see, the graph of the reciprocal of the quadratic actually has three components. The one L bracket, this upside down kind of parabola and quartic look, and then the other L bracket. Okay, so that's why these can look a bit busy at times. So label this g of x. And now we're going to analyze this in the chart below. So we know it has vertical asymptotes at x equals plus or minus 2, and no zeros because there's a horizontal asymptote. So what do we notice again here is that the zeros of the original became the vertical asymptotes of the reciprocal. So that's very similar to the previous example. The y-intercept. So the y-intercept is -1/4. Again, you can find that by subbing 0 into this equation. You can do g at 0 equals 1/0² minus 4, which equals -1/4. So that's how we get that. Again, you should notice it should be this number's reciprocal, and that's true. All right, now we're going to look at the interval where the function is positive. So where is the blue graph above the x-axis? It's above the x-axis for this area here, so from -∞ until -2, and then above also for this bracket, which is 2 to infinity. What do we notice again? They're the same. Where's the function negative? It's below the x-axis for this area here, and that's between -2 and 2. That is also the same as the original. Now the intervals of increase. So the intervals of increase, be very careful here. Remember, look at the blue. It is increasing for this area. Okay, follow the cursor. So from -∞ until -2. It is also increasing to the left of the vertex here. So it's increasing from here all the way up. So that is from -2 to 0. So those are our two intervals. Where is the interval decreasing? So it's decreasing to the right of the vertex here. So from 0 until it gets to the vertical asymptote 2, and then everything from here. So from 0 to 2, hop over 2 to infinity. So again, what you guys should be noticing is that these two should swap, okay? But remember, you have to consider the vertical asymptotes. So it's not going to be 0 infinity over here. But like I said, notice the end values here are 0 to infinity. Those should be the same end values for the two intervals here. However, you have to ask yourself, what is the vertical asymptote that occurs between 0 and infinity on the reciprocal? And the vertical asymptote in between there is 2. So you have to go 0 to 2, 2 to infinity. And it should match. Here, the boundary values are negative infinity and 0. So those should be the end values of your 2 over here as well, that I've highlighted. The vertical asymptote that appears in between this interval is at x equals negative 2. So that's why I go negative infinity, I stop at the VA, and then I hop over to the right of the VA, and then go to the end value of 0. So those should always switch. And here, these are going to be our points of intersection. And I just showed at the bottom here how you can see that even if I plugged in a y value of 1 into the reciprocal equation, when you cross multiply, what happens is you just get x squared minus 4 equals 1 back. And then as you can see, that is just the same thing as when we started up over here at the original. So that's why you get the same answer. Okay. So these should be points of intersection right here. Okay. So POIs. Okay, so hopefully we've taken that all in, and now we can summarize everything. So a lot of that is usually an investigation that you guys have to do on your own, but hopefully going through it like this made it a little easier. So let's turn to the next page, okay, and let's fill in everything we learned. So we know all the y-coordinates of reciprocal functions are the reciprocals of the y-coordinates of the originals. Okay, so if the original has a y-intercept at 0, 2, 5, then the reciprocal will have a y-intercept at 0, 5 over 2. The graph of the reciprocal function has a vertical asymptote at each 0 of the original function. Okay, so that means if f of x has a 0 at 5, 0, then the reciprocal has a vertical asymptote at x equals 5. Okay, so that matches. Okay, so then VA at x equals 5. A reciprocal function will always have y equals 0, okay, as a horizontal asymptote if the original function is linear or quadratic. Okay, and typically I only have you guys do reciprocal functions of linear and quadratic ones, so you always know the horizontal asymptote will be y equals 0. A reciprocal function has the same positive, negative intervals as the original. Okay, so if one function is above the x-axis for negative infinity to 3, then the reciprocal will also be above the x-axis over that interval. Obviously, it may have a different shape, but it should be above the x-axis. The intervals of increase of the original should become the intervals of decrease of the reciprocal. Right? We know those swap, and vice versa here. Intervals of decrease become intervals of increase for the reciprocal. So, and keep in mind here, let's fix this. So keep in mind here you have to consider your VAs. Okay. Okay, so write that in, consider your VAs. If the range of the original function includes y values of 1 or -1, the reciprocal function will intersect the original function at these same points. Okay, so just like I said before, please keep this in mind. It's POIs, so they will intersect when the y coordinate is plus or minus 1. Okay, not when x equals plus or minus 1. Now this is something that's a little new that you may not have noticed. Okay, and I'll scroll all the way down now. If the original function, okay, has a local minimum, so as you can see here with this, let's look at the diagram down here, this blue graph. The blue graph has a absolute minimum here, but we can also just refer to it as a minimum. If you notice, the reciprocal has the opposite. It has a maximum at that same x value. So the original had a minimum at x equals -1, so that's in blue here. Okay, so that's that point right there. Okay. And now the reciprocal has the opposite. It has a max at that same x value of -1. Okay. Now notice they can be different y values. Okay, so this one has a y value that's way up here. This one has a y value down there, obviously. In some cases, they can be the exact same point. In other cases, as we can see in the diagram here, they are completely different. And the same goes for vice versa. If the original graph has a local max or a max point, then its reciprocal will have a minimum at that same x value. Okay, but again, it can be a different y. All right, so now what we're going to do is we're going to use this information on this page to help us graph what the reciprocal graph will look like. Okay, so we have to use these facts to draw a graph now. Okay, so let's turn to the next page. And okay, before we start graphing that, let's just make sure we understand all the key pieces of information. So it says state the zeros of the original function and the vertical asymptote of its reciprocal. So these are both the originals. Okay. So this original here, if we want to find the zeros, we have to set y equal to 0 and solve for x. So as we go through that, we isolate for x, and we get that there is a 0 at -4 over 3. Okay. Which means that there would be a vertical asymptote on its reciprocal, 1 over 3x plus 4, at x equals -4 over 3. Remember, zeros of this become vertical asymptotes of the reciprocal. Same idea here. We need to figure out the x-intercepts, the zeros. So you set y equal to 0. And what happens here is that we're going to have to factor it. So we find two numbers that multiply to 6 and add to 5. That's 3 and 2. Because this is a complex trinomial, we have to use decomposition. Okay. So rewrite with decomposition, do our factoring by grouping. Okay. And we should get that our two zeros are x equals -3 over 2 and x equals -1. So if those are the zeros of the original, those are going to become the vertical asymptotes of the reciprocal. So remember, when you give equations of vertical asymptotes, you always have to have x equals in front of it. Okay, so let's start graphing reciprocals using all the information we know from the original. Okay. I encourage you to try pausing the video and trying doing this on your own at first, and then coming back and then going through it as well. Okay. So our original graph is f of x equals -4x minus 3. So when we draw that, okay, we know that is going to be a line, okay, that goes through a y-intercept of -3 and has a slope of -4 over 1. So this is going to be a line going down to the right. Okay, so that is negative, you're going to go down 4, right 1 from the y-intercept. So down 4, so our slope is going to be, that's a different color, slope will be negative 4 over 1, so draw that line now, and our y-intercept is negative 3. Okay. All right, once you've drawn that line, I'm not going to reveal the whole thing yet because it has both graphs on it. Okay, I want you to draw that on your own. And then I want you to ask yourself, what is the domain? Okay, so the domain of this should be XER because it's a line. Okay. The range of this should be YER, okay, because we know it's a line. In order to find the x-intercepts of this, it will be hard once you've drawn this line on a graph, it will be hard to see what the x-intercept is. So you can always find that algebraically by setting y equal to 0. So 0 equals negative 4x minus 3. Solve for x to get negative 3 over 4. Okay. All right, the positive intervals. So because this line is going down to the left, or sorry, down to the right, okay? So this line's going to go down to the right in your drawing, and it's going to cross through at negative 3 over 4. So that means it's going to be above the x-axis for everything before the x-intercept. So from negative infinity to negative 0.75. So again, you should be able to see that on the line that you've drawn on your page. Which means that the line goes below the x-axis after the x-intercept. So that's from negative 0.75, okay, just another way of writing negative 3 over 4, to infinity. Because this has a negative slope, there should be no intervals of increase. So no intervals of increase. And it's always decreasing, so decreasing from negative infinity to infinity. We also know that there's going to be points of intersection at y equals plus or minus 1. So what we need to do is we need to find out how I got these x coordinates. So that means you're going to come down here. Okay, move that a bit for now. Okay, and you're going to set, I'll reveal that after, but for example, you're going to do what we did in the previous two examples. You're going to set y equal to 1, okay, and then you're just going to bring over the 3, divide by negative 4, and get your x value. Okay, so everything you guys are used to already. Okay, so that becomes here. And then you're going to do the same thing with a y value of negative 1 here. And then you're going to get an x value of negative 1/2. Okay. So that's how you get those 2 points. These are very key when drawing because I need to be able to see that you know that the two graphs cross here. All right, so again, now we're going to fill in this side of the chart, knowing everything we know from the previous page and everything from this first column. So in terms of the domain, we know the domain will have restrictions if there's vertical asymptotes. So the reason why I said that x cannot equal negative 0.75 is because I know, I'll scroll down to here already, I know that there's going to be a vertical asymptote wherever there was a 0 here. So there's going to be a vertical asymptote at negative 3 over 4. Okay, or you can write negative 0.75. For the range, notice that I said y cannot equal 0. And the reason for that is because we know that these all have horizontal asymptotes at y equals 0. We know that the positive and negative intervals should be the same for both graphs. So I just transferred those same things over. Okay. So whatever that's there, Put it here, and this. Now remember, for increasing and decreasing intervals, these two should swap. They should swap, and then when we come up with the intervals here, these two should be the boundary values, but in between we should have to stop at negative 0.75. So notice, okay, that the interval of increase was these boundary values. Okay, so here and, I'll reveal that in a second. Here and here. Okay. So this and this should match here and here, except that we have to stop at the vertical asymptote, negative 0.75. And then whatever the increase was becomes the decrease, so none becomes none. And then of course we know down here that these 2 points should be the same, as they should be POIs. All right, I want you now to try to graph this. So graph 1 over negative 4x minus 3 just using this information. Okay, so you know when it's increasing and decreasing. You know when it's above or below the x-axis, and you know where the vertical and horizontal asymptotes are. Also be specific with these points as well. So you've got everything you need to graph. Once you do that, your graph should look like this. So again, pause the video at any time that you need to in order to do your writing, and then just press play again when you're ready. So as you can see, the black line there is my original function. So f of x equals negative 4x minus 3. And the purple dots are the POIs. I've got my asymptotes in there the best I can. I know it's hard to see negative 0.75, but the graph should cross at the purple dots, and you should see that all the other properties are matching from the table. Okay, so from now on, we use the first column here to fill in on our own, and then we use these characteristics to fill in this side of the column, and then use this column to draw it. Okay, that's the whole point of this lesson. All right, let's move on and do our last example. Again, I apologize for how long these questions are. There is a lot to go through. So if you're feeling overwhelmed, just take a break, pause the video when you need to, and then come back once you feel like you've absorbed everything. All right, we're going to do an example now with a quadratic. So f of x equals negative bracket x plus 4 all squared plus 1. So notice that this one is in vertex form from grade 10, aka it's in transformed function notation. All right, so in order to help us draw this, yes, I can see my vertex is going to be negative 4 and 1. Okay, but if you want some other key points, you can just do what I did at the top here. I did my, my table of values of the parent function, and then I did my mapping statement. So I knew it would be x minus 4, and then y times negative 1 because of the reflection, and then plus 1. So you can use this up here to create this drawing. So we know this is going to be a parabola with a vertex at negative 4 and 1. Okay, and reflected. What's really important here is, and it was nice that we can also see our zeros. Okay, so we can see we have zeros on our parabola of negative 5 and negative 3. Okay, so go ahead, draw that on your grid. Okay. So just so you can see a bit here, oops, sorry, your graph should look something like that. I don't want to show the other pieces yet, so I just want you to look at the blue part there. Okay, so that should be what your parabola looks like. Okay, so opening down with those zeros. All right, so how are we going to use that for filling out our table here? Okay, so remember the blue part is stuff you should be doing based on your knowledge of the original function. So parabolas have domain XER. The range, again, depends on the direction of opening of the parabola and the location of the vertex. So because it's opening down with the y-coordinate vertex for the vertex of 1, we're going to say y is less than or equal to 1. The zeros we could see are at -5 and at -3. The y-intercept. So again, you can find the y-intercept by setting 0 in for x. Okay, so we can do that at the side. Right, so f at 0 equals negative, and then we're going to get 0 plus 4 plus 1. Okay. So that's going to be negative, and then 0 plus 4 squared, so -16 plus 1. So that's how we get -15. Okay, and I apologize, it's hard to write with a mouse on here, so it looks a little messy. All right, now we need to know when the positive and negative intervals are. So that's going to be really important with your correct drawing. So again, I'm going to reveal that a bit here. Move this over a bit. Oops. Okay, so we can see in this blue drawing that it is above the x-axis for this part here. Okay, so that's between -5 and -3. And then it's below the x-axis to the left of the x-intercept and to the right of the x-intercept. Okay, so that's why we say it's above the x-axis between -5 and 3, and then below the x-axis from -infinity to -5, and then jump all the way over to the other x-intercept and -3 to infinity. Ignore these kind of green letters or green numbers right now. Just focus on the blue. So our increasing interval, because this parabola is opening downwards, it's going to be increasing to the left of its vertex. Okay, and we know its vertex occurs at -4 for the x-coordinate. So it's going to be increasing from -infinity to -4, and then it hits its vertex and decreases from -4 to infinity. All right, now we need to find the points where y equals plus or minus 1, because those will be points of intersection. Okay. So again, do the same strategy that we keep doing over and over again, okay, where we sub in for y and then we solve. Okay, and you should get these values. Now notice that I've added an extra line here, which says max or min at. Because with parabolas, we know parabolas will have a max or min. So we know automatically that their reciprocals, based on what we went over 2 pages ago, we know that their reciprocals will have the opposite at the same x value. So I'm noting to myself that the parabola has a max at x equals -4. Okay, so that means to me, I can kind of do this part now. Okay, that means to me that my reciprocal will have, so if there's a max at x equals -4 for the original, that means my reciprocal will have a min at x equals -4. Now it just so happens, okay, let's erase this. Okay, I'll show that a bit later. Just look at kind of these parts here. This blue part here is just showing you how we got this. Okay, so this blue part is just me showing how we got these values. All right, let's raise this up a bit. So what we need to do is keep in mind that they don't necessarily have the same y-coordinate. So what I do is I sub in -4 into my reciprocal function. Okay, so I do 1 over negative bracket 4 plus 4 all squared plus 1. Okay, so what happens here is that we get a y value of 1. Okay, I'm sorry, that should say -4. My apologies. Let me fix that. -4 right here. There we go. Right, because 1 over negative of -4 plus 4 will be 0 squared. -0 is just 0, 0 plus 1, so we get 1 over 1. So it just so happens that they're going to have a max and min at the same point. So not only the same x value, but also the same y value. But I want to highlight this because I want you to know that this isn't always the case. Okay? It's just a special case in this scenario. So in other cases, you may sub in -4 and maybe get a y value of 7, okay, or a y value of -2. Okay, so just in this case, they're the same. So we filled out that part. Okay, we already know that the points where y equals plus or minus 1 should be the same for both. And now let's go up and fill in the rest. Okay, so remember, you should be filling in this red chart, okay, before you do the graph. Okay, so we know the domain of the reciprocal is going to be x cannot equal, and then wherever the 2 zeros were of the original. We know that it's going to have a horizontal asymptote at y equals 0, because that's a rule for reciprocals of quadratics. Okay, so we know the range is restricted. We know we're going to have VAs wherever the zeros were here. Okay, so at x equals -5 and -3. We know the y-intercept is going to be the reciprocal of the original, so -1 over 15. Okay. And here we know that the positive and negative intervals should be the same. Now this part here, hopefully, okay, hopefully you can see here, remember, increasing and decreasing intervals have to swap. Okay, so if it was increasing on the original from -∞ to -4, this is where this green number comes into play. I want you to ask yourself, which of the 2 vertical asymptotes occurs within that interval? So, and the vertical asymptote is -5 occurs here. So that means my interval of decrease on the reciprocal will be -∞ to 5, and then -∞ to -5, and then -5 to -4. And then you see that here. Again, noticing, okay, that the end values match up here. Okay, stopping for the VA. The interval of decrease on the original is -4 to infinity. So that means it has to hit the vertical asymptote -3 at some point. So our first interval is going to be -4 to -3, and then -3 to infinity. So again, these should be the boundary values. And that's how we get that here. Okay. And you can put your, if you want, you can put the union symbol, okay, or you can do what I have up here, also a comma. It doesn't matter to me. Okay. All right, now we're going to use all of this lovely information, I know it's a lot, to draw the graph. So I want you to try doing that on your own. Okay, pause the video if you need to, and then double check to see if your graph looks like this. Okay. So you should have your blue graph there. Okay. And notice, here I'm going to kind of fix this a little bit so it crosses a bit better. Remember, they should intersect at plus or minus, at y equals plus or minus 1. So, right, so here they should intersect when you go across, and then at -1 they should intersect as you go across. Okay. So notice, because this one had a local max, the original, see how its reciprocal now has a local min. Okay? And like I said, it just so happens that these two y values were the same. So again, we've got this shape here, and we've got our two L brackets on the side in red. Don't forget to draw in your two vertical asymptotes at -5, -3, and your horizontal asymptote at y equals 0. And that is how you draw the graph of a reciprocal function of a quadratic using just what you know about the parabola. Okay. All right, you can all take a deep breath now. That was a very lengthy lesson, but keep in mind it's very nice. You can see here your homework. There's not too many questions, and that's because it is known how time-consuming it is. Okay, so everyone work on the homework and let me know if you have any questions about this and we can go over it. All right, thank you for listening. Get ready for 5.2.